Hey there guys, Mr. Strubar. Welcome to the pre-algebra video. We're talking about 11.6 today, which is all about permutations. So what's a permutation? Well, a permutation is an arrangement of objects in which order is actually important. Okay, so down here what I've done is I've written out different ways to write the letters A, B, and C, okay, without repetition, in as many ways as possible, right? So ABC is different than ACB, even though each of these contain the same exact letters, just a different order. So it's a permutation. This is exactly why I said in one of the other videos that we call it a combination lock really should be called a permutation lock, because 4, 6, 18 is not the same as 4, 18, 6, okay? Do they contain the same three numbers? Absolutely. But if this is the combination to your lock, this will not get it open. So it's a permutation lock, really, which is the same thing as saying ABC is different. ABC is different than ACB. Same exact letters, different orders. It's a permutation. So if we could count in this situation 1, 2, 3, 4, 5, 6. Okay, there's 6 different ways of ordering A, B, and C without repeating them, okay? But we're obviously going to encounter some situations where we're going to have more than just 3 options, okay? So the number of permutations is equal to the choices for the first times the choices for the second times the choices for the third. For example, if I choose A first, okay, well, how many choices did I have? I haven't chosen anything yet, so I had A, B, or C, so I had 3 choices. Then I go to pick my second letter. So we'll use this. I go to pick my second letter. Well, when I went to pick the second letter, I had from B and C to pick from. I couldn't choose A again. So I had 2 choices. Then my last letter, well, I already picked A. Then I picked B. The only one left to pick from is C, if we only have A, B, and C to pick from. And instead of writing C, I should put 1, because that's the number of choices. So the number of permutations is, in this case, we already said 6, but you could calculate that by doing 3 times 2 times 1, which gets you 6. So something else we need to know is what's called factorial. Okay, now factorial is it's a way of writing multiplication of many numbers. Okay, that go in descending order. So where we did this 3 times 2 times 1, right, and we got 6. What we would actually say is that is called 3 factorial. Okay, 3 times 2 times 1 is called 3 factorial. So what does that mean? It means 3 times 2 times 1. So real quick, just in your head, what do you think 6 factorial means? Well, hopefully you said 6 times 5 times 4 times 3 times 2 times 1. All right, 7 factorial, 7, 6, 5, 4, 3, 2, down to 1. All right, so next, let's say you're going to hang some posters in your room. So you guys might remember a similar example from last year. All right, so here's your room. Roughly, there's, bed and dresser and, I don't know. That's all you have. But you got 4 walls. That's awesome. A lot of people in this world don't have 4 walls. And you got some posters. Okay, so let's say you have 4 posters. That's a bad 4. 4 posters. And you have 4 walls, so you want to figure out. You want to hang 1 poster on each wall, and you want to figure out how many ways can you arrange these posters. All right. So let's say just for simplicity's sake, you have a black poster, a red poster, you got a blue poster, and then you've got a green poster. Okay. So if you put the black poster over here, you could then put the red poster there. And then if you've already used black and red, well then you've got to put blue either here or here. So let's say you put blue here, which then means the one left over is green, and you'd have to put him over there. But that's only one way of doing it. What if you did kept black over here, but you switched red to here and then blue to here and left green over there? Well, that's another way of doing it. So there's probably quite a few ways of doing this. So let's figure that out. Well, if we go back here and remember the number of permutations, which, again, order does matter here, because putting black, red, green, blue is different than doing black, blue, green, red. Okay, it's different. So we are talking about a permutation. You take the choices for the first times the choices for the second times the choices for the third. Okay, and you could keep on going. The fourth, choices for the fifth, choices for the sixth, as many options as you have. So how many options do we have? Well, we have 4 because we have 4 posters. So let's say we're working with a blank canvas again. I'll just kind of redraw the box for your room. Bigger pillow this time. And let's say you're going to hang a poster on this, we'll just say it's all the cardinal directions. So the west wall, north, east, south. You're going to hang a poster on the west wall first. How many options do you have? Well, you haven't hung anything yet. So you have a black, a red, a blue, and a green still to pick from. So the number of permutations is going to equal, well, the choices for your first wall is going to be 4. Okay, so let's say you put the black one there. Now how many choices do you have for this north wall? Let's say that's your second. Well, you've eliminated the black one, so you have red, blue, or green to pick from. So you have 3 to pick from, and let's say you do red there. Okay. Now you're going to move to the east wall. You've already used up red. So for the east wall, you can pick blue or green. So let's say you pick blue. All right, so then you cross that one out. Well, how many choices did you have for that wall? Well, you only had blue and green left, so you had 2 choices. And then this last one, the south wall, well, all you have is a green poster left, so you have 1 choice. And you put that green poster on that wall. So the permutations would be 4 times 3 times 2 times 1, which is the same as saying 12 times 2, which is 24. Okay, so you have 24 different ways you can hang or arrange those posters. So now let's switch it up just a little bit. All right, so let's say you have the same room, 4 walls, and now you have 7 posters though, but you can only hang 1 on each wall. So I'm going to draw kind of like, your poster slot. Hang 1 there, you can hang 1 there, you can hang 1 there above your dresser, and then you can hang 1 there. So now how many different ways can you do that? So why don't you take a second and see if you can solve this, and then play the video when you're done. Let's see how you do. So again, order matters here, because if I hang black, red, blue, yellow, that's different than doing black, blue, then red, then yellow. Okay, so order matters here. So what we're going to do is we're still finding the number of permutations. Okay, and again, that's equal to the choices for the first, times the choices for the second, times the choices for the third, times the choices for the fourth, and so on and so forth if you have more options. Now, let's go to this wall first. Okay, we'll start here on the west wall. How many choices do you have this time? Well, you have 1, 2, 3, 4, 5, 6, 7. Or you have 7 choices. So I'm going to take 7 times, and I'm going to move one of these over. So let's say you choose the purple poster for that wall. Okay, now you're on to this wall. How many choices do you have left? Well, you know what? You already, yeah, I'll mark through. It's fine. You already used the purple, so now you have 1, 2, 3, 4, 5, 6. You have 6 choices. Okay, so let's say you choose green. Now you go over to this wall. How many choices do you have? I already used green. Well, now you have 1, 2, 3, 4, 5. Okay, so let's say you choose the yellow poster. And again, we had 5 choices. Then for your last wall right here, you have, we use yellow, so we've used 1, 2, 3. So you have 1, 2, 3, 4 choices left. Okay, and let's say you pick red. Okay, so you use red. So left over, you have your black, you have blue, and you have your white. And you know what? That's okay. But you can only put 1 on each wall, so what we're going to say then is your permutation is actually equal to 7 times 6 times 5 times 4. So 7 times 6 times 5 times 4 ends up getting you 840 different, say, arrangements. Okay, with this given situation. Now, what if you had 7 walls? Okay, you could only put 1 on each wall. Well, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that would be 7 factorial if you had 7 walls. This is not 7 factorial. 7 factorial has to go all the way down to 1. Okay, 7, 6, 5, 4, 3, 2, 1. This is not 7 factorial, okay? This is just 7 times 6 times 5 times 4, which is good to be able to know, but it's not 7 factorial. So make sure you keep those things distinct. All right, so now let's talk about permutation form. Okay, permutation form looks like this: NPR, where N and R are going to become numbers. But what they stand for is this. P will stay the same, it means permutation. So what they stand for is this. N is the number of objects. So in our last example, we had 7 posters to choose from. Our R's are restriction. What were we restricted to? Well, we only had 4 walls. So that was our restriction. Now this would be then written, this NPR, is you take the number of objects and its factorial of it, and divide that by n minus r in the factorial of whatever that number is that you get inside the parentheses. So let's think about our poster example. Okay, let's do this. Number of objects. How many objects did we have to choose from? Well, we had 7 posters to begin with. Okay, big P. And then over here, R, what was our restriction? Well, we only had 4 walls. So if I want to figure out the number of permutations, what we could do is this. Take my n factorial, okay? So this is n factorial is going to be whatever that little number in front of the p is, factorial. So 7 factorial really means what? 7 times 6 times 5 times 4 times 3 times 2 times 1. So we'll get there in a second. Over n minus r in the factorial of that. So in parentheses down here, n minus r. Well, n is our 7, r is our 4, so 7 minus 4, and we take the factorial of that. So let's keep on moving with this and simplifying this fraction. Again, 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 4 is 3 factorial, which means 3 times 2 times 1. Now I have multiplication separating everything on top, multiplication separating everything on bottom, which is cool because that means I can do some canceling. 1 on top, 1 on bottom. 2 on top, 2 on bottom. 3 on top, 3 on bottom. All I'm really left with on the bottom is the invisible 1. Okay? But really we can just pretend it's not there, and whatever we get on top, that'll be our answer. So 7 times 6 times 5 times 4 on top. Whatever that is, it'll be our answer. So 7 times 6 times 5 times 4, we get 840, which conveniently enough is the same answer we got when we did it the long way up here with our drawing and everything. Okay? All right, so I want you to try this one on your own. Pause the video when you're done. You have 24 posters, or play the video when you're done. You have 24 posters to choose from, but you only have room for 15. So how many different ways or permutations are there? So go ahead and try this and let's see what you get. Okay, so we really want to practice this factorial form, which is NPR, kind of like the radio broadcast, NPR, on talk radio. Yeah, probably don't know what that is. Well, I hope you do. If you don't, you should. But anyway, NPR. So here's the deal. Remember, N stands for our number of options we have. Okay, so how many options do we have? Well, it says we have 24 posters. That's great. So I'm going to put 24 down there, big P, and then my R. Again, my R is restriction. Am I restricted in any way? Yeah, but only have room for 15. I'm limited to 15. So let's go ahead and figure this out. So again, our permutation form looks like NPR is the same as saying n factorial over n minus r factorial. So in this case, what's my n? Let's worry about the top of our fraction. What's my n? Well, it's 24, and I need to take the factorial of that. Okay? Over, well, what's n minus r? Well, n is 24, and I got to subtract from that 15. And then when I'm all done with that, I'm still going to have to take the factorial of whatever answer that is. So this is our setup. So 24 factorial means 24 times 23 times 22 times 20. This is going to get tedious. So I'm going to do ... times 1 over, what's 24 minus 15? Well, it's 9. Okay, so 9, then factorial means 9 times 8 times 7 times 6 times 5 times 4, so it's not as bad, times 3 times 2 times 1. Alright, so you can see this is going to get pretty tedious. So how can we simplify this process? Well, you all have a TI-84. right? And there's a couple of reasons for that. This is one of them. We can actually use our TI-84 in this situation to help us out. So on the top, we have 24 factorial. So I'm kind of going backwards. Okay, 24 factorial. We're dividing that by, we said 12 or 24 minus 15 factorial, which we found was 9 factorial. Okay. So what's really cool is your TI-84, you can do this. Go ahead and click 2, 4, then hit the math button, okay, which is going to be on the left-hand column, third from the top. And then when you get there, you're going to scroll all the way over on the columns till you get to PRB, which stands for probability. And then you're going to scroll down until you see the little exclamation point, okay? And if you do 24 factorial, what I get in my calculator is 6.204484017 times 10 to the 23rd. Okay, so that is a very, very large number. Not incredibly easy to work with. So instead of sticking with that, here's what I think we should do. Go back and clear out your calculator. And now what I want you to do in your calculator is type in this, okay? I want you to do parentheses 24 and then go ahead and go to math, over to probability, down to the exclamation point, and then hit that, which is factorial. Then hit divide by, or I guess in your calculator it'll look like this. I want you to do parentheses. Always good to add some parentheses in there, make sure we're grouping things right. 9, and then do the same thing. Go to math, over to probability, down to, or PRB, and then down to the exclamation point. Okay? So it should look like that in your calculator. Now, when you hit enter, what you should get that to equal is 1.709789467 times 10 to the 18th. So a very, very, very large number. But what does that mean in our situation? Well, you had 24 posters to choose from, only had 15, room for 15. How many different ways can you do that, or how many permutations? This many. A whole ton. All right, guys, that's all I have for you. Thanks for sticking with it. Look forward to seeing you in class and talking more about permutations.